Hey guys, welcome in to class today. Obviously, I'm not there. I apologize for that. I got a sick kid at home, so I'm working to help her feel better, that kind of thing. So, apologize for not being there, but this is a notes video to go along with your notes for today. It's our second day working through point slope form and answering some questions that way. So, when you guys work through these point slope examples, going to look at how we can write in point slope form, how we can graph based off that, how we can find our different pieces and parts to our linear equation that we need to, and also if we need to go back between point slope form and slope intercept form, take a look at that as well. Okay, so give yourselves a couple minutes to try these warm-up questions. You can even pause this video and then come back into this, and we'll kind of check our work here based on writing these in point slope form and then converting the equation that's in point slope form to slope intercept form in standard form. All right, so when we look at these first examples, right, when we're taking a look at this, it says to write in point slope form. So remember, our point slope form looks like this, right, where we've got that point, and our slope, we're going to take our y value minus y1, so the y coordinate they give us, and that's equal to our slope, m, and then times x minus x1 in parentheses. So if you look at this, we've already got our slope identified for these two examples. We have our x and y. We just need to rewrite the equation here in that point slope form. So when I look at this one, the big thing that stands out to me is this y value. It's a -8 for this first one. So when I write this, if it's minus a -8, right, minus a negative, that ends up adding. So we're thinking opposite here, right, of what we see. So when we've got that, we have y equals +8, because minus a -8 would be like adding 8. And then our slope is a -2, and then in parentheses times x minus 1, since it's a positive value. So there's my first equation there in point slope form based on that point and based on my slope. For the second one, I have another negative number. This time it's my x value. So I'm going to think about that when I'm writing this. So it's going to be y minus 7, because it's y minus my y1, which is 7 here, is equal to that -2/3 for my slope. And then in parentheses, when I look at this, since this is a -3, right, x minus a -3, subtracting a negative is really like adding a positive. So that would be my equation here in point slope form. So I've got my two examples there along with my actual formula, and that's what I'm looking at. Okay, this next one is already given to us, right? Already given to us in point slope form. And so when we answer that one, what they want us to do is convert it to slope intercept form and then standard form. So we're going to convert to slope intercept, which is y equals mx plus b, where m is my slope and b is my y-intercept. And then my standard form is ax plus by is equal to c. And remember, a has to be positive in this example. So we're making sure a is positive when we're writing that out. Okay, so if I do this first one, I'm actually going to distribute first, because I can go ahead and do that, and that'll help me get to slope intercept form. And I think from slope intercept form, it should be easy then to go to standard form. So when I look at this, I've got y plus 8. That part is not changing, okay, and that's equal to a -4 times a positive 3x would be -12x, and a -4 times a -1 is actually positive 4, okay? So if I'm looking at this and I want to be in slope intercept form, I want to isolate the y. What has to move then is this +8. So I'm going to subtract it from both sides from its like term. And so then in slope intercept form, I get an equation that is y equals -12x, with that being my slope, -12, and then actually plus, right, plus, or actually in this case minus, because we have a positive 4, -8, so that would be -4. So there's my equation in slope intercept form. If I want to go to standard form, right, I want to make sure my x and y are on the same side, right? My x and y terms are on the same side, and I need to make sure this x, this a term that's the coefficient or attached to x, is positive. So this actually works really well. All I really need to do, if I want to put this in standard form, is actually move this -12x to this side, right? Get rid of it over here. That way I can make my a value positive. So I'm going to add that 12x to both sides. So if I rewrite this in standard form, it's going to be 12x plus y plus 1y is equal to -4. And that gives me what I'm looking for. My ax and by, those terms are on the same side. That's equal to my constant, which is -4. And I could go ahead and find my x and y intercepts based off that, since it's in standard form. So a little bit of review of the last few days of this. So hopefully you did well with that. If you need to take a look at it again, you can. Otherwise, go ahead and feel free to move on in the note. All right, the next page actually in your notes here is something that'll be posted in Schoology too. I'll post these notes in Schoology from today. But when you look at this, this is the answer key from yesterday's assignment. When you look at it and you're trying to look at your equations in point slope form, okay, you can kind of take a look at that. There's a couple down here that are highlighted, number 7 and number 8, because you'll notice when you simplify, right, when you simplify these things, on number 7, for example, it ends up being y minus 0, so it's not necessary to have that minus 0 as a final point of the, or part of the equation in point slope form. Same thing happens over here. If I do my distributive property, I take a negative 2 times x to get negative 2x, but then a negative 2 times a negative 0. That basically cancels out as well. So when you look at that, just a couple ones that are highlighted there. So if you get stuck on something like that, take a look at that. I'll have you guys turn in this tomorrow when I'm back in class. So if you didn't quite get it all the way finished, you can kind of take a look at that answer key as well to go through and answer some of your questions, okay? All right, so let's jump into just another set or another part of this, kind of how we talk about what we're looking at and how we use our point slope form. So it says, given 2 points, write the equation in point slope form and slope intercept form. So here's our steps that we're going to do. If we're given 2 points, right, we're going to write the equation in point slope form and slope intercept form. All right, and the way that we're going to do that is to follow these steps. We're going to find the slope using the slope formula, okay? Right, find the slope using the slope formula. And then we're going to pick a point and plug m into this equation. So remember our slope formula, when we find that, is y2 minus y1 over x2 minus x1. It's the change in y over change in x. Okay, and then once we do that, we're going to pick a point that is given to us and plug it in, and also plug our slope that we just found into our point slope form. We're going to distribute and then solve for y. Okay, so we're going to get point slope form first and then jump into slope intercept form. So our first example of this, as we take a look at it, make my pen a little bit neater here for you guys. First example is we've got the points with my x and y values -1 and 0, right? And then my x and y of 1 and 2. So I'm going to find the slope first. So I'm going to do y2 minus y1 minus, there we go, over x2 minus x1 to get my slope. So my second y value here is 2 minus my first y value, which is 0. And all that's going to be over the change in x, which is my x2 of 1 minus a -1, because that's my x1 that I'm looking at there, right? x1, y1, x2, y2. Okay, so 2 minus 0 is my change in my y values. That's a change in 2 units, okay, over 1 minus -1, which is really like I'm adding here. So 2, right? So 1 minus a -1 would be 2, and so I end up with 2 over 2, or just 1. So my slope is 1 here when I'm doing this, all right? And a lot of times, again, it's easier to plug in values where there's a 0, right, or no negative numbers. So you choose when it says pick a point and plug. Okay, I'm actually going to use the one without any negatives this time, so I'm going to plug in this as my value. So I'm going to pick a point and plug that into, these are both positive as well, so that'll work really nice. I'm going to plug that into my point slope form. So I'm going to take y minus 2, right, because that's a positive 2, is equal to my slope, which is 1, okay, and then times x minus 1 is what I'm getting here. Okay, so I'm going to distribute, and the good thing about distributing by 1 is you get the exact same thing, right? So when I do that, I get y minus 2 is equal to just x minus 1 when I multiply there. And then I'm going to solve for y. Well, if I solve for y, I need to get y by itself, which means the only term that's moving is this constant 2 that's on the left, or yeah, the left-hand side. So I'm going to add 2 to both sides, add 2 over here where I can do that. So I end up with y equals x, 1x, right? That's my slope. And then it actually ends up being plus 1 as my solution here when I write that equation. So again, remember, we followed these steps, right? Found the slope using the slope formula, picked a point and plugged it in along with the m value that we found in our point slope. And then once we distribute here and solve for y, put it back in slope intercept form, we get that equation, which would be really good for graphing, right? A lot of times we think about slope-intercept form. That's what we're trying to do in order to graph the situation or scenario. So just keep that in mind when you're answering some of these questions. All right, so let's take a look at a couple more here, just as some examples to go through. So got my 2 points here, right? Think of this as your x1, y1, and your x2, y2 when you're looking at it. Same thing over here, x1, y1, and x2, y2 when we're answering these questions. So first thing I'm going to do is find my slope, right? Change in y over change in x. So y2 minus y1, in this case it'd be 0 minus a negative 1. 0 minus a negative 1, and then a negative 6 minus a negative 4 is what I'm looking at for my slope in this first one. Okay, end up adding here because it's minus a negative, so this would be 1. End up adding here as well because it's minus a negative as well, and that would actually be negative 2. So my slope is actually negative 1/2 in this example. When I do that, 0 minus a negative 1 is 1, positive 1, and a negative 6 minus a negative 4 would be adding 2. So that's what we get as an answer there. All right. So then what we do in our second step is we plug that into our point slope formula with one of the values. So I'm going to go ahead and use this point this time, right? So I'm going to do y minus my y value, which is 0. Okay, since it's positive. 0 is just a positive number, right? Even though it's nothing, has no value, and that's equal to negative 1/2. That's my slope. And then x, in this case, since it's negative 6, minus a negative would really be like adding, so I'm going to do plus 6. Okay, in my third step, I distribute, and then in my fourth step, we solve for y. So I'm left with y minus 0 is equal to a negative 1/2 x, and then a negative times a positive is a negative, and 1/2 of 6 is 3. Okay, and then here's the really good thing, right? If I'm solving for y in my last step, well, if I'm subtracting 0, adding 0 doesn't do anything, right, to any of this. So y equals negative 1/2 x minus 3 is my answer to my equation. All right, pause the video and try the next example, and then we'll go over it together. All right, guys, so hopefully you took the time here to take a look at this one. And when you answer it, right, something you'll probably notice when you first find your slope, when you're doing this and you first find your slope here, using that slope formula, okay, y2 minus y1 ends up being negative 1 minus negative 1. So negative 1 minus a negative is really like adding. So I end up with 0, right? And then 2 minus 6, when I do x2 minus x1 is a negative 4. Well, 0 divided by anything is 0, so that means there's no slope, right? No slope, and that means if there's no slope, there's no vertical change over horizontal change. And so that's when it's an example where y equals something. In this case, you'll notice both your y values are at negative 1, and that's the case for every point on this graph. It would be a horizontal line across where y equals negative 1. All right, so now we're into writing an equation of a line passing through the given points. So through these given points in point slope form and slope intercept form. Okay, so point slope form and in slope intercept form. So again, basically we're going through those 4 steps, right, where we find our slope, we plug in our slope and our point, one of our points given, right, and then we distribute and we solve for y. So we're going to end up getting to slope intercept form. So first thing I need to do is find my slope here. This is my x1, y1. This is my x2, y2 in this example. y2 is 3 minus y1, which is 0, over x2 minus x1. So that's 1 minus a negative 2. Oops, negative 2. There we go. This ends up being positive, right, when we have minus a negative. So I'm looking at 3 over 3 this time, because 3 minus 0 would be 3. 1 minus a negative 2 is really adding, and so my slope ends up being 1. So I'm going to go ahead and use 1, 3 as my point here because I like points that don't have negatives in them. 0 can be our friend, but again, we like those without negatives. So I'm going to use 1, 3 as my point and write this in point slope form. So I'm going to take y minus 3 is equal to my slope here, which is 1 times x minus 1. That's what I'm looking at, right? That's my x value. So the good thing then is to distribute this, right, and go ahead and do that. And I take 1 times anything, I get that same value. So I'm looking at y minus 3 is equal to just x minus 1 when I do that, okay? And then my last step is to solve for y to make this in slope intercept form. So when I do that, right, This would be point slope form right here. And then my slope intercept form is what I get in the end when I solve for y. So I need to get rid of that minus 3 to get to slope intercept form. So I'm going to add 3 to both sides, and I end up with y equals x. A negative 1 plus 3 would be plus 2. So y equals x plus 2, where 1 is my slope, 2 would be my y-intercept. So I have my slope-intercept form and my point slope form. All right, take a minute here, pause the video, and try doing the same steps with the second example over here. All right, guys, so it's something about that second example in each section here, right? So when we look at this one, if we find our slope by using that slope formula when we're answering the question here, right, my y2 minus my y1 is 1 minus a negative 5. So minus a negative would be like adding, and I get 6 there. But then you'll notice I have a 3 in my x2 and a 3 in my x1. Well, 3 minus 3 is 0. Remember, 6 divided by 0, or anything divided by 0, we can't do that, right? We type that in our calculator, we get error. Can't take whole parts or whole numbers here and divide it into nothing. So this is one of those undefined examples, which means you would have a graph where it's x equals the same value. In this case, it's x is equal to 3. So if we looked at a graph, if we were to graph this, we don't really have a slope-intercept or point-slope form here. Since the slope is undefined, it would be a vertical line where all of your x points are 3 on the graph, and that's what that one looks like as that example. All right, so now we're looking at actual graphs here, right? And it says write an equation in point-slope form. Point-slope form is what I'm looking at here when I answer this question, okay? And so remember, when we're in point-slope form, we're thinking y minus y1 is equal to the slope, right, times, in parentheses, x minus x1. So I need a point that's on the line, and I need my slope is what I need. So here's a really good thing about this, right? I can find any point that's going to match perfectly on the line. So let's go ahead and go with, this point right here that's on the line. All right, that can help me create this in point-slope form. That point right there is at when my x is 2, my y is negative 1. So 2, negative 1 is my point. Okay, and if I want to find my slope, I can use any of these other points that are on this line, right, that fit perfectly on there, and I can look at my vertical change over my horizontal change. So I'm looking at kind of creating a stair step in a negative direction. It looks like I'm going down 1. That's my vertical change, and over 2. So it looks like my slope would be negative 1/2. So if I write this in point slope form, right, when I'm using my point and my slope that I found based on this graph, I could say y minus my y value. So that's minus a negative 1. So really that's going to be y plus 1 here, because that's my y value. This is my x. And that's equal to my slope, which is negative 1/2, and then times x minus my x value. In this case, it's positive, so it's minus 2. And there's my slope, point slope form with this slope of on the line and a point that I used, right? I could have used any of these. I could have used 0, 0. I could have used negative 2, 1 as a point. I could have used what? 1, 2, 3, 4, 1, 2. So negative 4, 2. I could have used that. I also could have used the point 1, 2, 3, 4, and negative 2. 4 and negative 2. Any of those would have worked to write this equation in point slope form. The second one over here says to write an equation in point slope form of the line with the given slope through the given point, and then graph the line, okay? Graph the line. So the good thing is here, right, if I want to write the equation in point slope form, again, I'm just thinking in terms of what this looks like right here. So if I want to write that in point slope form, okay, I'm going to use my point, my x and my y and my slope to do this. So y minus, it's a positive value, so minus 4 is equal to negative 3/4, right, and then times x, and in this case it's a negative number, so minus and negatives are like adding, so it'd be like x plus 4. So there's my equation in point slope form, okay? And then it says graph the line. So I could use this equation, or I could literally just use this point at negative 4, 1, 2, 3, 4, and positive 4, 1, 2, 3, 4. I could start here, and since I know the slope, right, it's a negative 3/4, I could go ahead and graph this. So I'm going to go down 1, 2, 3, and over 1, 2, 3, 4 to the right, make a new point, down 1, 2, 3, and over 1, 2, 3, 4, and make another point. And those are really the only ones that are going to fit on this graph as I create it here and make my line. So the good thing is if I have a slope, right, and I have a point to go off of, I can go ahead and create that graph, and I've got my point slope form of the equation as well. And so that's what I'm looking at when I'm filling this out. All right, so here's 2 more examples. So why don't you guys take a couple minutes here and pause this and then try to work on finding your solutions for these like we did those last 2. All right, so the one on the left here says write an equation in point slope form. So I've got 3 points on the line here at -4, 2, at 0, 3, and at 1, 2, 3, 4, 4 that are actually on the line. So I could use any one of these points. I just use the one where I had 2 positive values, right? My slope is 1/4 because if I look at this line from a point that's on each coordinate, that fits perfectly. My vertical change is 1 over my horizontal change of 4. I'm going up 1 over 4. Each time it's a positive 1/4 because of the direction it's going. So I'm looking at positive 1/4 and then 4, 4 is my answer there. So when I rewrite this in point slope form with 4, 4 being my values, right, for x and y, I have y minus 4 is equal to that 1/4 slope, and then times x minus 4 there in point slope form. The next one says to write an equation in slope intercept form, so I need to get to y equals mx plus b, right, with the line given the slope and given the point, and then you graph the line. So the good thing is I can actually graph this line, because if I go to 2, -3, I'm right here, right? 2, -3 was right here. And then I go up 1, 2, 3, 4 over 1, up 1, 2, 3, 4 over 1. But the problem is I can't get all the way to my y-intercept, right? And this last part isn't straight, so I apologize for that. But when you look at this, right, this is what you want to do. And then you put it in your point slope form, which is what I did. So if my y value was -3, I actually get y plus 3, since that's a negative. And it's equal to my slope of 4 times x minus 2, okay? So then I distribute here in this step, and I get y plus 3 is equal to 4x minus 8. And so then to rewrite this in slope intercept form, I then subtract that constant 3 from this side to get y by itself, or isolate it. So y equals the 4x, and then it's minus 11 because I had the minus 8 and minus 3 here. So my y-intercept's actually down here at 0, -11. If we continued this line, my slope is 4, and that's how I would graph the equation there. All right, so one last thing we'll look at today is this writing equations using a table, okay? So one way that we can do this and look at this, right, is think of our change in y over our change in x when we see this, right? And so when we see a table, especially a 2-column table like this, our x values are usually on the left with our y values on the right. So we're going to write an equation of the function that represents the table, okay, and then we're going to write it in point slope form. That's the idea here. So there's 3 steps to do this. We pick 2 points, okay? So in this case, it looks like they pick your positive values, which makes sense, right? When your x is 5, your y is 40, and then when your x is 11, your y is 58. So they pick the 2 positive values, which is probably a good idea. We're then going to calculate the slope. So remember, right, that is when we do m equals our y2 minus y1 over x2 minus x1 when we're doing that, okay? And then we pick 1 point to substitute the slope, pick 1 point and substitute the slope and the point into our formula to put it into point slope form. So in this example, what they did then was they found their slope by taking 58 taking that 58 minus 40, right, to get 18 over 11 minus 5, the change in your x's, right? If this is x1, y1, x2, y2, okay? So they get 18 over 6, which can be simplified to 3 or 3 over 1. So then what they do then is they plug in, they're using the 0.540 and the slope of 3. They plug that into your formula here. Remember, it's y minus y1 is equal to your slope, and then times the quantity of x minus x1. And that's what they do right down here, right? When you look at this, they take y minus 40, because that's your y value. It's equal to 3 times x minus 5, because that is your answer there. All right, so you can find that. You can substitute those values and then rewrite it, in this case, in point slope form. So on the next 2, we're going to do this really quick here. Okay, on these next 2, you're going to write the equation, model the linear function, write the equation in point slope form, and then convert to slope intercept form. Okay, so again, this one can be tricky at times, but I would pick the ones that you think might be the easiest to deal with. So let's just go with these 2 points here, and let's find our slope first, because remember, if we think back to this, what we're going to do is pick 2 points, and then we're going to calculate the slope. So if I have the point 2, -3, if that's one of them, and then 5, -9 when I do this, okay? My y2 minus my y1 is going to be a -9 slope. Make sure you write that. -9 minus -3. Okay, so it's really going to be like adding that value, right? And then my x2 minus my x1 is 5 minus 2 here. So a -9, it ends up being +3 since it's minus a negative. It's going to give me a -6. 5 minus 2 is a +3. A negative divided by a positive is a negative, and I get -2. So my slope is -2 here. So then the second step, remember, or the third step, sorry, pick one point and substitute the slope and the point in your formula and rewrite this. So we're going to rewrite this in point slope form first before we can convert it. Okay, I'm going to use this point, and I already have my slope of -2. So I'm going to say y plus, in this case, since it's a -3 value, right, minus a negative would make that positive, and that's equal to my -2 slope that I got here times x, and it's -2 since that was positive there. Okay, I've got to distribute before I can isolate and write in slope-intercept form. So I get y plus 3 is equal to a -2x plus 4 on this one. That's what I'm looking at. So then if I go one step further to get it into my slope-intercept form, I'm actually going to take away 3 on both sides to get y by itself, and a -2x, there's my slope, -2. 4 plus a -3 is just 1. So plus 1 would be my y-intercept there. Okay. Last example, and then you guys can take a look at a few things before you get to your homework today. So this says, write an equation, it's modeled in your function, write the equation in point slope form, and then we're going to convert to standard form this time. These are all positive. We're looking at speed limit, so miles per hour, and you're fine, okay? So speed over the speed limit, and you're fine. That makes sense. You probably wouldn't pay a fine if you're not going over the speed limit. So I'm going to use the two smaller values. I just think that would be easier in this example. So I have 10 and 75, right? That's my x1. This is my y1. And then I have 12 and 95. When I look at that, that's my x2 and my y2. So I'm going to look at the change in the fine amount over the change in the speed that's happening here, right? So I'm going to take, if I'm looking at my slope, I'm going to take 95 minus 75 as an example over 12 minus 10. So in this example, if we're kind of interpreting what this means, if it's a change in $20, right, that's a change in 2 miles per hour, which is also like saying 10 over 1, right? Or $10 for every mile per hour. What happens here? Miles per hour that you go over the speed limit, okay? So just keep that in mind when we're answering these questions. So we need our slope. We need one of our points. I'm going to come back and use that as my point to rewrite this. So I'm going to say y minus 75 because that's my y value originally. My slope was 10 times, and then it's x minus 10 because that's my x value here. I would then distribute. So I want to do first. So y minus my 75 is equal to 10x minus 100, right? Then what's happening here is I'm going to rewrite this probably in y-intercept form, right, first. Or I could actually I could think of it, or instead of doing slope-intercept form, let's just go ahead and move these two terms, right? Because that would end up giving me, if I want to be in standard form, remember when we think about standard form, that's ax plus by equals c. And I want my a to be positive. Well, right now my a is already positive, so let's not even move that. Let's move this, and let's move this, because that will get me to where my x and y are on the same side, and my a is going to remain positive. So I'm going to take away a y on both sides, take away a y over here, and I'm going to add 100 on both sides, add 100 over here. So what I'm left with is negative 75 plus 100, which would give me 25, positive 25. And then over here I've got my 10x minus y, and there's my answer in standard form, right? I could find my x and y intercepts on this one by plugging in a 0 for x or a 0 for y, but it's in standard form because I've got that positive a value. X and y are both on the same side in terms of those terms, and then my other side is that constant c number. In this case, it's 25, okay? So that's how we look at that. Last thing that I want to show you guys really quick here, and I'll let you get to your homework assignment, and hopefully you've got a little bit of time to do that. Graphing linear equations, right? There's 3 different forms. We've seen 3 forms that we've been dealing with, and we can go back and forth between the 3 depending on what it's asking us to do. Slope-intercept form, right? This is your slope. This is your y-intercept right here when you're looking at that. So this, a lot of times when we're graphing, is the best one. okay, to do that. All right, so plot your y-intercept. You can count the slope, which is your rise or run. Remember, that's your vertical change over your horizontal change when it says rise over run. It's another way to think about that. And then just an example of that would be, when you look at this, if you're writing that out, would be y equals 3x plus 4, where this is your slope of 3, and your y-intercept would be at 0, 4 when you answer that one, okay? Standard form is a good one if we're looking for our x and y-intercepts. And the way that we do that, right, is we make sure that this is positive. It has to be positive, right? Our a value's got to be positive for this to be in standard form. And we want to have x and y on the same side. If we want to find our x-intercept, we plug a 0 in for y and cover that up and then solve. If we want to find our y-intercept, we plug a 0 in for x and cover up and solve. So an example of what that could look like is 3x plus 2y equals -6. We can have negative numbers. That's okay as long as it's not that a value. And then point slope, what we've worked on the last couple days, right, is if you have a point and the slope and you're looking for this, so you plot the point, you can count your slope. Again, rise over run is another way of saying vertical change over that horizontal change when you're looking at it. And just an example here would be where you're looking at this, right, and your slope would be 3 for this one. And then the point, since this is +2, would be -2. And since this is -1, +1 would be your point there. And you could use that to graph and help you answer the questions. Okay? So just a few things to consider there and talk about with what we see in these type of problems. Okay? You guys have your homework assignment that should be given to you by the sub. It is a worksheet. One side's a puzzle practice with point slope form. The other one is where you actually graph and look at that. So make sure that you're getting those two things done, both sides, and ready to turn in and on class on Thursday. If you guys have questions, just reach out to me via email. I'll check that throughout the day while I'm home with my daughter, and I will see you guys in class on Thursday.